Yeah.
I think this is it.
Oh.
There we go. So on Code Forces it says it's going to start in a few minutes, but I think we should be mostly ready here.
There you go.
Good morning, everybody. Who will be watching this in the future? Oh, we have 24 people watching already. Look at that. Good morning. Good morning, Satyam. We're gonna give it a couple minutes here. I mean, maybe just like 2 minutes. I know we've got geothermal stream is also happening at the moment right now. So if there's a little bit of we're competing for viewership, that's fine. We might be watching his stream at the end for the solution to problem F, because we only have A through E figured out. And then some rough ideas for F. So welcome everyone. This is my brother Thomas.
Hello.
He also goes to UCF on the UCF Varsity Programming team, which is where I learned a lot of my stuff myself. And we both did Educational Round 120 this morning. So we'll talk about the solutions to that in just a minute here. Thomas, how are you?
Pretty good.
Oscar wants to know.
Pretty good. How are you guys doing?
You're watching both streams. Man, that's impressive. That takes one in each ear, right? Okay, so yeah, we're gonna jump into problem A then. Well, I guess we'll give people another 10 seconds here. What did you guys think of the set? Did you like it? Oh, Thomas's handle. Good question.
Yeah.
Timmy Thinmints. So I can go open up his profile here. Yeah, you're about to get a whole bunch of friends, Thomas.
About to get a whole bunch of friends. That's good.
So here's my brother, Timmy Thinmints.
It's yeah, on a little bit of a downward trajectory over the past few months, past few weeks.
He's a Cyan, worth about 1,000th of Umnic, so that's fine, you know. So yeah, that's him. All right, it is officially 10:45. Time to go. Are there any audio bad? Really? Why is the audio bad? What's wrong with the audio? Is the audio actually bad? Can you tell me what's wrong about the audio? I don't know. Tricky. Well, we're gonna just keep going with the audio how it is. Sorry about that. I guess we can turn it down a little bit in case it's too loud. Maybe, is that better? Okay. Well. All right. So back to the contest. So let's talk about problem. Let's start with problem A, I guess. Do you want to talk about what problem A was on the whiteboard? Here?
Yeah, sure.
Alright, so the idea behind the problem, we'll have Thomas explain this one here, is that you've got some sticks. I think you've got 3 sticks originally. So maybe your sticks are like this, this, and then this as well. And you want to cut one of the sticks in some way so that you have a rectangle after cutting it. The sticks all have to be cut into integer lengths, and then you want to see if it's possible.
Yeah.
So what was your approach, Thomas?
So I said that there were 2 different possible ways that you could make a rectangle with these sticks. Either you would have, let's say, sticks like 1, 2, and 3.
Are these like sorted?
Yeah, I just did all the different permutations, combinations. Just like went through them. It doesn't even matter.
Okay.
I mean, there's 3 sticks. You can just brute force it, right? So you just say like, let's say 1 is equal to 2, and 3 is an even number, right?
Yeah, your handwriting is horrendous.
Okay, well, here, let's. All right. Okay. So 1 is equal to 2 and 3 is even. That means that you can do 1 and 2, and then you can do like 1/2 of 3 here, and then like the other half of 3 here. And 3 just like splits in half, top and bottom, and then 1 and 2 are on the sides.
Yep. So this is the first way,
Yeah.
and then there's the second way, right?
And then the second way is if 3 is equal to 1 plus 2.
Voice is echoing. Why is the voice echoing? Okay.
I don't know if you can do much about that.
That's a problem. Try this. How's this audio?
I think your master volume is still good.
No, it should be fine.
Okay.
Now is it good? Give it a few seconds here. Yes, no, better, worse? No voice at all? Audio should be on now, though. Fine now. That's fine, that's fine. All right.
Okay, good.
We're going to this. Okay,
Cool.
so the second way is, when the two numbers add up to the same.
Yeah. Why is this
Similar to before. Well, okay.
Like-
We're just going to leave it like this. I'll figure it out. I'll figure it out for next time. Yeah,
Okay.
so
Um,
then you just do like
yeah.
1, 2, and then you copy them with like 3 and 3.
Yeah. So you can split 3 into the sections that are equal to 1 and the section that's equal to 2. And then it's just mirrored.
Okay. Yeah. So that's kind of simple. There you go. Kind of a simple problem A. I'll show you the code for it real quick in case you're interested in that. Where is the code? There you go. Code for problem A. So the way I did it was a little bit different, maybe a little bit better, maybe a little worse. But the idea was, if you sort them, then you only have to check the first or the last element for being even, and the third element would be the only type of case 2. So the third element would be the sum of the first 2. That's the only one you have to check. All right. Some people want to hear about C. Can we speed up a bit? Yeah, we'll speed up. All right, let's talk about B. So B is probably a bit quicker, right, than A, because A is pretty simple. Everybody knows how to do it. What was B? Do you remember?
There's like songs and permutations of the songs. And then you had to rate the songs, and then you wanted to...
Oh yeah. So you want each song that you upvote to be better than each song you downvote, and then you want to change the values of each song in the smallest way possible. So, like if you have some good songs, we'll do good in paint. Well, good in blue, bad in black. So let's say your good ones are rated like 1, 5, and 3. And then the bad ones are rated 4 and 2. So these are the songs from 1 to 5. If you want the bad ones to all be lower than the good ones, then you want these orders to stay the same, right? So if you thought that the 4 was better before, you want to still think that it's better. So you have like the 2 black nodes will be here, and then the 3 good nodes will be like this. So relatively, they would be 2 and then 1, and then the blue would be 3, 4, and 5. So you just keep the relative order the same. Can't see the board, really. Okay, I don't know how we're gonna fix that. How does it look here? Oh, cause yeah. There you go. Relative order the same. Board very far away indeed. There you go. You can see it now though.
Alright, sounds good.
Nice and clear. Okay, so yeah, that's the idea to B. We'll keep her moving though. On to C. I think I just drew a dot on my leg. Okay. Yeah, where's the eraser? Here. I guess it was fine before. The problem's just the camera was wrong. Alright, so problem C. Thomas, how many wrong submits did you have on problem C by the end of the contest?
I think it's 15.
15?
Might have been 16, yeah.
Well, you know what they say. 16th tries a charm.
16th or 17th.
17th prime.
17th prime.
Prime numbers come into play in problem math. Okay, so since you clearly spent a lot of time thinking about it, what's the problem? Or not the issue with your solution, but like what problem are you trying to solve?
Let me pull it up.
Yeah, I guess, sure.
I'm going to pull it up for everyone, but just like...
Set or decrease, yeah.
Yeah, so you have some set of numbers, and in that set, you can do one of two things. You can either decrease one of the numbers, or you can set any of the numbers to another number. And then you want to minimize the number of steps you take, which, at least for my approach, which isn't right, but like kind of the idea is that you're going to decrease one number really far down, and then set the bigger numbers to the really small number that you decreased. And then finding out how many steps you need to do is the problem there.
So for this example, if you want the sum less than or equal to 8, what we could do is, well, this is the best move, is the best thing you can do, like set this to 1 and then set this to 1. Like just do 2 sets?
Yes.
Then you have the sum of 8? Okay.
Yes.
So this you do no decrements, but you might need to do decrements in general.
Yeah, you could do decrement, but...
I'll do a decrement and then a set?
Yeah, either.
Okay, yeah. Yeah. So, okay, I guess first, like, what were you trying?
So, I had the correct solution. It was just too slow.
Well, hang on, what was the correct solution? You had a solution that gave the right answer.
I had a solution that gave the right answer.
Sure.
It was just too slow.
Yeah.
And this was because I was decrementing by 1 when I was decrementing.
You didn't need a binary search. Binary search was not necessary.
Yeah. So the numbers go up to 10 to the 9. So if you have really big numbers and you need to decrement 10 to the 9 times, it's going to be too slow. I tried decrementing, like...
So what did you do? Like,
So-
did you decrement and do sets at the same time? Like, do
No,
whichever gave you the better benefit?
Yes. So I would say, like, I'd have, like, basically... So I sorted the numbers, right?
Yeah.
And then I say...
And the smallest one's what you're going to decrement, because it's,
Yep.
like, and then you set everything from that, yeah?
Yeah. And then I would just have, like, an indice of my right pointer. And that was an index of my right pointer.
Yeah.
And that would be, at the end, like, what I would be setting all those numbers to.
Mm-hmm.
So then, let's say... And then I would keep a running sum of that total of those. So...
Yeah, so, like, you sort them, and then you've got, like, some 1s here, some 2s, and then, like, a 3. So then, like, this is the one that you're going to decrement.
Yeah.
And then you're going to repeatedly, like, set these to your smallest value.
Yeah. So I'd, like, put the 3 in my pile, and then, because, like, it's better to decrease 3 to 1 than it is to decrement 1, and then I would, like, put 2 in my pile, and then you can just compute that in O of 1 every time.
So lots of questions about what should we call Thomas. So yeah, if you want, you can be the third thread. He is my younger brother, if that matters. I don't know if you can tell. He's still in college right now, so he's my younger brother. He's like 3.5 years younger than me.
Yeah.
So you can call him third thread.
That's funny.
Maybe second thread is my my dad. But yeah, so I don't know. Yeah, you can be third thread, I guess, or just Thomas. You just call him Thomas. Thomas works too. Third thread it is. Okay, so yeah, so this approach is correct, I believe. I actually implemented it myself during contest. This was my first TLE, and I implemented it, and like, I'm an idiot. Like, this clearly doesn't work. So obviously, like, the reason it doesn't is because the number of steps you might need to take can be really big.
Yeah.
Like, you might need to do a whole bunch of decrements.
So the reason I had 15 submits was I thought that maybe with each time, instead of decrementing by 1, you could decrement some number in between 1 and the like the difference you need to get to, and then you could divide that by some number.
I'll like try decrementing by multiple things for like a square root factor or something.
Yeah, that's what I was thinking.
Yeah, that becomes less right all of a sudden.
So it does get you wrong answers sometimes and TLEs sometimes.
His handle is Timmy Thin Mints. I showed it earlier on in the stream. So we're not going to explain this part a bit more because this is incorrect.
Yeah.
Like this is basically a completely different path than the right solution path, but is one that you would, or at least both I and my brother first thought of and thought it was right. So let's talk about the right solution here. I'm sure you're interested in hearing this, Thomas, because very, very involved in the problem. So, okay, so here's the idea. Obviously, it should be pretty clear from like a gritty observation that first you're going to do a bunch of decrements. After you do decrements, you're going to do a bunch of sets. You're only going to decrement one number. It's going to be the smallest. You decrement that a bunch and then set everything else to it. And that should be pretty obvious. So like here, we're going to take the smallest one, decrement it a bunch, and then set other things to it. We might not decrement it at all, but we're not going to set anything to anything else. Like it's pretty straightforward. So, okay, so that's what we're going to do. But we can't iterate on the number of total moves. However, we know the size of the input is relatively small.
10 to the 5.
So yeah, we have 10 to the 5th things, like elements. So, if we brute force how many of those elements we end up setting to the smallest number, then we just have to be able to solve that part in order 1. That's the idea. So like, let's say we know there are going to be 3 elements we set to the smallest number. The question is, what does that smallest number need to be?
Yeah.
Right. So obviously the 3 numbers in this case that we would set to the smallest number would be the 3 biggest. So first we would sort these, and then we would have like 1, 1, 1, 1, 2, 2, 3. So we brute force how many we're going to set. That's going to be this suffix. And we're going to set these all to the smallest number. And the question is, like the smallest number will be this 1 here. So everything else will be the same. And you can binary search this, I guess, if you want. You can binary search how much you need to decrement it by. But you can also just do some division. Like, you know, this will decrease by 2 minus 1 plus 2 minus 1 plus 3 minus 1. And then plus 4 times however much, like, you subtract. So, yeah, so you know, like, this will decrease your sum to a certain number. In this case, it'd be fine, like, you're already past the total. But you say like, okay, I need to decrease, maybe like you need to subtract another 10 from your total. And in that case, if you have 4 numbers here, like each time you subtract 1 from this, you would have subtracted the 1 first, so then you would also subtract 1 from this, this, and this. So now every time you subtract 1, you really subtract 4. If you need to subtract another 10, then you do 10 plus 4 ceilinged, or that's like 10 plus 3 divided by 4 floored. So that's the idea. Hopefully that makes sense.
Yeah.
Let's see the solution. There you go. Yep. You got wrong answer for submission to B. You got it very first time. Well, nice job. Yeah, yeah.
Yeah, wrong.
You can binary search the total number of operations too, I guess. Yeah, so that was the C solution right there. So the idea is we brute force which suffix we're going to end up setting. And then once we know the suffix, we know how many more turns, or how many more like total we need to save by decreasing. And once you know how many you're going to save by decreasing, that's like, you can just math out how many decreases you need. Because you know each time you decrease, it saves 4, so you can math it out. All right, that's C. Moving on to D. How to do it with binary search? Yeah, so really quickly, if you know how many decreases you have, you can calculate the sum. So if you don't want to do any math, if you know you're going to do 4 decreases, and you know there are 4 things, that will decrease it by 4, right? So let's say we know we're going to do 4 decreases. That means this 1 will get set to minus 3. And then we're brute forcing the number of things we do here.
Set to -1.
Yeah, we brute force the number of things we set to -1, or set to the first element on the outside. And then we say we're doing 4 decreases, so then we can set all of these to this first element, which is -3. Yeah, tourist is here. Oh man, Gennady, great to see you. If this is really you, congratulations, man. Thank you for joining. Yeah, if it's a clone, it's very convincing. Okay, let's talk about D here. Shuffle. Did you read this at all? No. Okay, well I guess I'll be explaining it then. And then maybe I'll give you a second to think while I explain it. So, in this problem, you've got a binary string of 1s and 0s. Let's give a decent example here. The first sample was actually pretty good. Pretty interesting. So you have 1, 1, 0, 0, 1, 1, 0. Okay. So now you can pick any substring of this string, and you can shuffle it in whatever way you want. But there is a restriction, which is the substring has to have exactly k 1 bits. In this example, k is equal to 2. So one substring you could pick would be this substring here. So 1001. You're going to do one of these operations, not as many as you want. And the question is, if you do just this one operation, what other strings can you reach? So in this example, one string you could reach would be that. So we shuffled these 4 elements, the rest stayed in place. So the question is, how many strings can you reach under mod? Because this can be a very big number. Does the problem make sense?
Wait, what is k?
K is the number of ones that have to be in what
sure,
you
sure.
pick.
Yeah. And
So-
this is just a potential string you could reach.
This is one of them that you can reach,
Yeah,
but you
yeah.
can reach a bunch.
Sure.
In this case, I think you can reach 16. I know because it's given right in front of me.
What is...
Bounds are nice and small. So bounds are n and k are less than or equal to 5,000. So you can do like sum n squared. And in fact, the solution ends up being n squared. Oh, Light Sam's here. Welcome, Light Sam. I think Light Sam's a mod. Should we make Gennady a mod? He's either the real guy or he put in the effort, right? Oh wait, yeah. So either way, welcome. You're now a mod, tourist. Okay, so here's the idea. There's a little bit of a tricky situation here. So the first thing to keep in mind is it's very similar to like stars and bars. We can consider the bars being the ones because they look like bars, but also because like if we have some window, it's going to span, like in this example, the window that we can shuffle from, it spans like some number of ones. So we have like one window here. This is like a maximal window. Then we have a maximal window here, a maximal window here, and that's it. Like those are our 3 maximal windows. And within each maximal window, we can put the zeros in any of the positions. So, yeah. The problem is there's some overcount. In particular, like let's look at this string. Like when do we hit this string? So you hit this string with sorry, we're back. We are back. Oops. All right. So sorry about that. Battery died. Yeah. Apologies. Back alive. Okay. So what I was saying is that when you have when you have like some string, in order to avoid this overcount issue, what you can do is define the bucket that a string should go to as the bucket with like the left endpoint equal to the first 0 gap that moved. So you've got like this 0 gap here, and this is different from what it was before. It used to be 0, now it's 2. That's of course very annoying to count. So what you can do is just brute force what's the size of this first 0 gap. So yeah, so what we're gonna do is like we have all of these windows. For each window, we're gonna say like brute force the window. And then we're gonna brute force the size of the first 0 gap. In particular, like, it has to be different. Like the first 0 gap has to be visibly changed. Because if it's the same number of zeros as it was before, then it would be counted otherwise. Okay, cool. Yeah. Sounds good. So, all right, that's problem D. Hopefully that made sense. And we've got problem E as well. So let's look at problem E. And then, yeah, I guess if you have any... You just hit a string too hard. Not sure. I added it stars and bars. Yeah, so I guess the ones are bars, zeros are stars. Can I repeat what I said? Okay, sure. real quick, speed run. So, we have a bunch of these windows, right? The zeros are the stars, the ones are the bars. We can pick some range, and then within that range, do stars and bars. In particular, we can move the zeros around, but the ones stay where they are. Then, the problem with this is that we'll double count some things. So, if we have this string here, this will get double counted with both the range of the 2 middle ones, and also the range with the first 2 ones. Because both only use zeros that are in both of those ranges. However, it's like the same thing. So to avoid this overcount, we're going to say that we want to assign this string in order to be counted by the second 2 ones, because we want the first group that's in this stars and bars range to change. That way we know if you look at some string, you could find the first one that changed, and then you can say this was counted exactly once. It was counted by the time when the range was this. So yeah, that's how we do that. Then to actually solve that part, we're going to brute force what the window is, and then we brute force what the first group between 2 ones changes to. How many zeros are then in that group? Okay, hopefully that's good. Yeah, we'll do random questions at the end, if you like. All right, so let's talk about E here, problem E. Yeah, math test. Okay, so this problem was a bit confusing, but here's the idea. We have up to 10 students. So we have n less than or equal to 10, which screams 2 to the n. And then we have m less than or equal to 10 to the 4 questions on this test. Each student will have an answer to each question, and each student gets each question right or wrong. So let's say we have n equals 3, and then m equals 4. So maybe the answers are like 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1. Which means student 1 gets the first and last question right, student 2 gets these 2 right, and student 4 gets all of them right. Also, each student has a predicted, expected score. So in this case, maybe this student expects to get 5 points. This student expects to get 3 points. And this student, well, he knows he got them all right, but maybe he's just really dumb somehow, and he still expects to only get 3 points. So what you're going to do is assign point values to each question in order to maximize the surprise of all students. So a student's surprised by the difference of what they actually scored versus what they expected to score, and you want to maximize that difference. So the absolute value summed over everyone. So let's say the actual values, maybe they were just 1, 2, 3, and 4. They're worth some permutation. So this first student gets 1 plus 4 points, which is equal to 5, so he has a surprise of 0. The next one actually did get 3 points, so he has a surprise of 0 as well. And the next one gets 7 plus 3, which is 10. So he has a surprise of 7. So what we need to do is pick this permutation here in the best way possible. So we want to pick this bottom permutation so that we maximize the surprise. So here, 5 and 5, these differ by 0. So we get like plus 0 here, we get plus 0 here, and then we get plus 7 here. We can do better though. A better example might be if we did 4, 3, 2, 1. Not even better is 4, 3, 1, 2. If we did this, then the scores are 4 plus 2 is 6. 4 plus 3 is 7. And then we have 10 again. So this guy is also surprised by 7. This is now 4, and this is now 1. So it's some better. So the question is, what is the best one of these that we can pick among all n factorial? So do you have any ideas, Thomas? What are you thinking?
Not that many people.
There are not that many people.
There are a lot of questions though. You.
So this like absolute value stuff is really annoying. Like when we're trying to optimize stuff, having absolute values in the thing we're optimizing for is very tricky.
It's like going either direction.
Yeah.
Yeah.
So how could we like get rid of the absolute values?
I don't know.
Like what if we knew which direction each absolute value was going to go in?
You could. You could. I don't know. Oh well, I mean.
How many possible ways are there in total?
2 to the 10. No.
Yeah, 2 to the 10.
2 to the 10.
Because
Yeah.
the first one you can either score too well or too badly.
Yeah.
The next one you can score better than expected or worse than expected.
Yeah. It's just 10 bits.
Yeah, so you have 10 bits.
Yeah.
So we could do that. We could brute force for each question, or for each person, does the person score better or worse than what they were expecting to? And we want them to be as wrong as possible, right? So, yeah, so what does this look like? Well, if we have more whiteboards, that would be nice. But we've got something like this. So we would have like score 1 minus expected 1. And then we have like expected 2 minus score 2. Maybe because this person like was going the other way, and maybe we have like score 3 minus expected 3. So yeah, for this, like we have a bunch of these things, but we can like combine the scores and the expecteds. So basically we have like score 1 minus score 2 plus score 3. And then we have minus expected 1 plus expected 2 minus expected 3. So the important part is that if we're brute forcing what this 2 to the n thing is, this part is just a constant.
Yeah.
So the expected scores don't matter at all, really.
Yeah.
Like, it's just some constant. So we want to optimize for
Interesting.
this thing, but this part's just a constant. So no matter like this part is determined by how we choose the permutation.
Yeah.
But this part isn't. Like, no matter which permutation we choose, this will be the same. So we want to choose the permutation in such a way that we make this as big as possible. Because this thing over here is what we are trying to maximize. Does that make sense?
Yeah.
So we're trying to maximize this. We just like changed the order of the terms. This part's going to be the same no matter what. This part is what we want to make as big as possible.
Well, this won't always be the same for all permutations, will it be?
Well, for different permutations, this will be the same for all permutations. Because like the score someone expects to get doesn't matter.
But whether it's positive or negative does.
That's only for the bit mask.
Okay, I see. Yeah.
So if you have a different bit mask, this will be different. But
Yeah,
we're just
that
going to
makes
do
sense.
one bit mask and then like pick it over the
Yeah,
best bit mask. Okay, so yeah, so now the question is like, how do we like make this as big as possible for the permutations? Yeah, so we have like, okay, so here's like the second part of the problem. I'm gonna erase this because I need more space. But for a given question, let's look at this question here. the number of points that we give to this question will impact the scores. So if both of these people are expected to do worse than what we thought they would, if they're worse than their expected score, that means the absolute value will be expected minus this. Which means both of these will be like negative ones. Because these S2 and S3 will be negative. In this case, S2 is negative, S3 is positive.
Yeah.
So this will contribute like -1 to the total. This will contribute +1 to the total. Because this like S2, S3, for this question too, it'll be -1 +1.
Yeah.
Let's make these negative and this positive here. So now we have -1, -1. So the amount this will contribute to the final answer will be whatever black number we pick here. So maybe it'll be like 2. It'll be 2 times -1 times -1. 2 times -1, I guess plus -1 actually. So it'll be -2. So in this case, we want to sort the questions by their net value, if that makes sense. Are people very confused here? What's going on?
No.
Something geothermal something F?
It's on the stream right now.
Yeah, geothermal stream's going on right now, so if you're looking for that, you can check them out. Otherwise, we might actually just kind of watch it, and then we'll like stream it here, watch it, and then talk about F after, to learn from him. But definitely go subscribe to Geothermal's channel if you haven't. He's a very good YouTuber.
Also, we are
Very
in Wisconsin, in America. It just snowed, so it is a little bit cold, a little bit snowy outside.
Yeah, it's very, very chilly out.
Yeah.
So that's the idea. So we're gonna, I guess the TLDR here is first we're gonna brute force for each person, whether they score higher or lower than their expected value. So there are 2 to the n things there. Once we've done that, and we do that because like the absolute values are really hard to optimize through.
Yeah.
Once we do that, then we can figure out like what the expected value part of this equation is, and then we just want to optimize the actual score part of the equation. To optimize the score part, we say for each question, like some people this will be negative for, some people will be positive for, depending on this bit mask. So if it's negative or positive, then like you add that to your total. And then you want to assign the most negative questions to the worst scores, like the least important scores, because you're trying to maximize it. All right, that's the idea. Okay, so how's this going? People are saying hi. So many geniosities here. Is there a playlist for DSA? Okay. Awesome. It's snowing outside and you're in t-shirts. We usually wear shorts. I'm only wearing pants because it's a little bit more fancy. But yeah, my brother Joseph was outside in shorts like 5 seconds ago. I have 3 brothers, by the way. Okay, yeah, is Geothermal explaining F? Do we want to just like watch Geothermal stream here? And then, is this like legal? Do you know?
Oh yeah.
Do people on Twitch do this?
This is the only thing people on Twitch do.
Okay. Let's do it. Okay.
This is the Twitch meta.
So, Twitch meta time. Alright. People, you'll have to let me know if you can see or if you can hear
For example,
what Geothermal's saying.
The hash of 10 factorial is equal to the hash of 9 factorial times 10, which is equal to the hash of 9 factorial XOR
Oh,
the hash
hashes.
of 10, which is hash of 9 factorial XOR hash of 5 XOR hash of 2. And so we can get these values just by factoring all of the numbers and going from there.
Okay. YouTube is filling me. Okay. This is definitely problem F. Let's go back a bit, maybe. So, yeah, I guess let's talk about what problem F is first, maybe. That might be more useful. Because you haven't even heard of Thomas.
Nope.
So, okay, so problem F. So, what is problem F? So, you know what a square number is, surely?
Like 16?
Oh, before we start, hang on, let me just say. There was this Who Wants to Be a Millionaire episode. I'm sure someone will link it in the chat. But there was this Who Wants to Be a Millionaire episode. And one of the questions was, which of these square numbers is the sum of two other square numbers? And the choices were 16, 25, 36, and whatever said 49. So which square number is the sum of two other square numbers? And the guy didn't know, which was, first of all, kind of embarrassing. But then he used Ask the Audience. The audience had it was like 45% of people said A. Both in the room and worldwide. 45% of people thought 16 was the sum of two square numbers.
Oh, yeah, we got most.
What do we have?
Yeah, that's right.
Lots of 25s,
That's right.
115, which is certainly a typo. Yeah.
Anyone?
There you go.
Yeah,
this
yeah.
is not a joke. Like, this actually happened. You can look it up. It's okay. Anyway,
Pretty bad, yeah.
So those are like what normal humans have to deal with. They go through their life just totally clueless. Sorry. No, if you didn't know, that's fine. No, you watched it like an hour ago. Exactly. Yeah, in the contest, I'm sure. Yeah. So, oh man, that makes you just want to rip your hair out, doesn't it? So this problem, bit harder. The question is like, we're gonna define a bunch of integers as being a quadratic set if you take the factorials of all the numbers, then you multiply those factorials together if that number is a square.
Huh.
Let me give you an example.
Wow.
4, 3. This is a quadratic set. Sorry. Oh man. Okay, you'll get a square number again. Yeah, it'll be. Okay, screen crash. Back in a minute.
There we go.
Black screens matter. So, this is a square number. I don't know exactly what it is, but I can tell you it's square. The reason that it's square, are people complaining still? BSM? Yeah, we already explained A through E. So you can go back and watch them if you're looking for those. Can I see the... They can, yeah.
Yeah.
So the reason this is square is 3 times 3 is square, right? That's 3 squared.
Sure.
2 times 2 is square.
Oh, yeah.
These multiplied together will be a square times a square.
Oh, and 4 is also a square.
And 4 is a square.
There you go.
So this is, in fact, a square set, or a quadratic set. Okay, so the question is, given n, you have some number n up to 1,000,000. The question is, find the biggest possible set of integers where this entire set together is square.
Like the most number of them?
Yeah, you need the most integers in this set.
Wow.
Yeah. So it's pretty tricky, but it gets a little bit simpler than you might think. So like, let's look for each number. Let's look at like what it is. So to check if a number is square, you just need all prime factors of that number to be square. Right. So like all prime factors need to have an even exponent, basically.
Okay.
Does that make sense? Yeah. Because like, if all prime factors have an even exponent, you can like take each prime factor and the exponent over 2, and then that'll be the same thing squared. So okay, 1 is just like an empty set, so 2 just has the 2. 3, like 3 factorial will be 3 times the 2, so it'll have the 3 and the 2. 4 will have the 4, but the 4 is square, so it's basically just the 3 and the 2. 5 will have the 5 times this, so it'll be 5, 3, 2. 6 will have 6 has a 3 and a 2 in it, right? So it gets rid of this 3 and the 2
Nice, it's just the empty.
because they come
6.
like
It's 3 times 2, yeah.
You get this thing times 6, so the 3 and the 2
Oh, you get the 5.
become even. So it's just the 5, yeah. 7, you have 7 and 5. 8, so 8 is 2 cubed. So you have a 7, a 5, and then an odd number of 2s.
Yeah.
So you have 7, 5, and 2. Okay. 9, you have
3.
2 3s.
2 3s.
9 is 3 squared.
Oh, yeah.
So the 3 doesn't actually count here.
Interesting.
So you've got just the 7, 5, and 2. So, like, one thing you can do is anytime you have a square number and one less than a square number, that will be square.
Oh, yeah. There you go.
Right, so these are the same, 4 and 3 are the same. So you can do something there. Like, that's an answer. It's certainly not the best. But then you run into these weird problems, like, what's the sample? Can you open up the sample?
Here?
Yeah, but just click on problem F. They give you this really weird example. It's, I think it might be this, actually. Yeah. So here you can get rid of this and this,
Yeah.
and it works. You said yeah immediately. To me, it's really hard to see why this works. 7 appears an even number of times. 5 appears 4 times. 3 appears 1, 2 twice. 2 appears 1, 2, 3, 4 times.
Well, those are both one less than the perfect squares.
So,
Well, that's the connection I made.
but 1 is also one. Well, yeah, 1 is also one less than a perfect square.
Yeah.
I don't think that's true in general. I
No,
don't think you can just like
it doesn't.
subtract the things that are 1 less than a square and it works. Because like you add 10, 10's not 1 less than a square.
Oh.
But
Yeah.
10 will definitely change it.
Mm-hmm.
So it's not true. So that's the question. So now we are on a quest to figure out how to solve this problem. Oh, blessed dest! Yes! Please explain in the chat. Let's hear it. Let's hear it. We're gonna... Thank you. Blessed... Okay, for everyone who doesn't know, blessed dest is like... I don't know him. Or her. Could be her. But he is the author of Global Round 18. Biggest failure in my history! So yeah. Thank you. Okay, the answer is always close to n. It's at least n minus 3.
At
Really?
least n minus 3.
That is insane. Why is it always at least n minus 3? That's wacky. N minus 3, it's so big.
Well.
Alright, now hang on, everybody. Blessed us. You gotta tell us why. You can't just say that and then leave.
It's really typing.
Oh, fire fingers here. The answer is always at least n minus 3. So, like, you can always, when you're done, you'll have, yeah, logic, please. Can we get some?
Yeah.
Yeah, why is the answer always n minus 3? That's a very brave thing to just say. Maybe we'll just believe it on blind faith for now, but...
They solved it?
What? He could, he's good. I mean, he wrote the Global Round, so...
Yeah.
To be fair, I also wrote Facebook Hacker Finals and then solved 3 problems on the Global Round, but... Alright, well, let's bless, come on. The entire stream is counting on you, blessed dest. I keep saying blessed, there's no S. It's bled dest. Bledest?
Bled.
Bledest? Is it one like...
The other D is capitalized, though.
Bled dest. Yeah, I don't know.
Oh, okay.
So first of all, 1 factorial is equal to... What? What? Hold up a minute. I don't believe you for a minute. 1 times 2 times 3 is equal to k. Really? Wait, why is that? Okay, let's sanity check that.
1 factorial, 2 factorial.
Okay, hang on, Thomas.
Yeah.
Thomas. We need to make sure this is actually true. There's some Someone that could be totally trolling us here. No, I believe it, but it's just this is too crazy to be true. So they're telling me that if I go up to 6, this will give me just 6. For real. What? So they're saying if we all of these numbers together will give us just 3 and 2. That's what the claim is.
Yes.
Which in fact is the case. Why would that be? Okay, maybe. So like plus 3. So you get 3 and 2 here. Why is that?
3. Yeah, that's right.
Is that proof by brute forcer? Okay. 2k double factorial.
Oh.
Oh. Apparently you meant 2k double factorial in the first message.
Yeah.
What is 2k double factorial? Is this like 2k factorial? Or not k double factorial, 2k double factorial? Oh, so 6 double factorial? What? So k, in this case k equals 3. So 2k is 6. So what are they saying? They're saying, oh, which is k times k minus 2 times k minus 4. Oh, interesting. Okay, times 2k is equal to k double factorial. So, well, that's just not true for this, is it? Like 3 double factorial is just 3. Oh, maybe meant 2k double factorial.
Yeah, 2k.
So 6 times 4 times 2. 6 times 4 times 2 is not right. 6 is 2 times 3. 4 is 2 times 2. 2 is 2. 6. Like this gives us, if we only care about these things, it gives us, what does it give us? Just a 3 and the 2, right? So,
Yeah.
3 and a 2. Wait, not a 2. Oh, just a
Just
3.
a 3. Yeah,
Whoa,
it's just a 3.
okay, just a 3. Okay, this gives us a 3. So what is the claim is it's 6 double factorial. Oh, which it is. Oh man. Okay. All right, chat is flying. Chat is flying. Okay, what the hell k is double factorial? Where to learn DS and algo? The internet. I don't know. Okay. Well, okay. Can we stop it with the? Okay. Unknown. If you keep it with the stop, you're gonna get banned here. You're gonna get banned. Chill it with the stop emoji, please. We can consider the result of n mod 4. Okay. Tourist has joined the stream, I think. What the hell is k double factorial? So okay, let's talk about this. So k double factorial. So, like, let's do 10 double factorial is equal to 10 times 8 times 6 times 4 times 2. Like you just keep subtracting 2 each time. You got D2, nicely done, nicely done. Okay. Blessed, or bled, blessed. Man, I'm just renaming this guy blessed over here. Bled? Bledest?
Bloodest.
Bledest. Bledest. Bledest is saying we consider the result of n mod 4. N mod 4. N mod 4.
Shouldn't.
So n mod 4 is, well, obviously n mod 4 is either 0, 1, 2, or 3. For n mod 4 equals 0, it's always possible to take all numbers except n over 2 in the answer. So it's n minus 1. What the heck? So they're telling me when n is 8, I can keep everything except for 4, and it just works. So, okay, what is 8 double factorial? You got 8, 6, 4, 2.
Yeah.
So they're saying we want to remove... Oh, we remove 4 factorial over 4 factorial. Oh, which is kind of cool. Look at this. 4, 3, 2, 1.
Oh yeah, look at that.
That's kind of neat. Which is equal to 2 to the 4.
Oh.
That's obscene. Like, how do you even see that? Okay. Alright. Alright, continue reading double chat. Alright, lots of stuff is happening. Lots of stuff is happening. Okay. The thing about tourist in friend list is when he solved B, he already solved E. Clown, yeah, that's true. I know, he was so quick this round. I was like, oh darn, I just got a wrong answer. I think I got a wrong answer on C, and it's like, oh, tourist is almost done. Okay, which problem? We're on problem F. We are like, what's it called? When you have a bunch of people solve something? Crowdsourcing. We're crowdsourcing the solution to problem F, because the editorial's not out yet. Double factorial of a non-negative integer is the product of all integers from 1 to n that have the same parity as n. That's another way of finding out that works. Okay, in 1 factorial times 2 factorial up to n factorial, n repeats these, n repeats once, n minus 1 repeats twice, n minus 2 repeats thrice. Oh! Oh, that's so cool!
So that's a double factorial?
No, that's why it works. Oh, that's awesome. Okay. Look at that. Look at this. Oh, that's so cool. Okay, ready?
Yeah.
This is awesome. Okay, you've got 10 factorial, 9 factorial, 8 factorial, 7 factorial, and so on.
This is 10 double factorial.
So this is no. This is like if we want to include all of the numbers from 1 to 10.
Okay.
This is what we get, right?
Sure.
So this is 10, 9, 8, 7, and so on.
Yeah.
This is 9, 8, 7.
Okay.
This is 8, 7, and so on, and this is 7 and so on. In all of these columns, we have 1 10. So we have a 10 here, because we don't care about squares. This is a square.
Yeah.
So we can get rid of the 9s.
Oh, I see.
This is an 8, we can get rid of all but 2 of them, because these make a square.
This is why the double factorial works.
So this is where the double factorial is coming from.
Sure.
And then we have a bunch of 6s, so this is where the double factorial comes from.
Yeah, that makes sense.
So, yeah, okay. And then this is how you get rid of it, and you just turn it into 2 to the whatever. Anytime you have, like, a multiple of 4 things.
Yeah.
Okay. Yes! That is so cool. Okay, so we have the solution to n modulo 4 equals 0. That's easy. So this is like remove n over 2 factorial. Okay, alright. That is so cool! So cool. Gennady, that is epic. Okay. Alright, Bloodest, do you got, are you gonna give us the other values for n mod 4 here? Or you gotta go here? Should we try and figure them out? I guess n mod 4 equals 2 sounds plausible. Or sounds like the next easiest thing.
N mod 4 equals 2.
N mod 4 equals 2.
Well...
So what do we have in that case?
Like...
Then we've got like 10, 8,
Yeah.
6, 4, 2, and then 6, 4, 2. So
You would...
what if we get rid of 5 factorial? Then we have a 2 left over. Oh, 5 factorial and 2. So 5, 4,
Yeah.
3, 2, 1, and then we also need a over 2.
Okay.
So this will give, because this is
yeah.
equal to 2 to the 5th.
Yeah.
Yeah. Okay. So this one we just get rid of n over 2 factorial. This one we also just get rid of n over 2 factorial and then get rid of 2. Check the last message for n over 2. Okay. So for even, ooh, what? what is being claimed? So since for even n, 1 times 2 blah 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 is equivalent to n over 2 factorial times 2 to the n over 2, it's always enough to take out either n over 2 or n over 2 and 2, and the answer for n mod 2 is 0. For n mod 2, is it? Oh, it's at least n over 2. Yeah, so we got that. We're with you there. Please do more live streams like this with a guy with rating maybe less than 1500. Are you less than 1500?
What is what's
Thomas is cyan at the moment.
Yeah.
I'm glad, to be honest though, I'm glad that you like that he's not just like a genius over here.
No.
Like it makes it easier for several reasons, but
I think around 1500.
hopefully in the future if I keep doing them with Thomas. I mean, the fact that oh yes, bless. That way your thing is highlighted.
We can all be.
You definitely deserve to be a moderator. No,
Can all
not
be
timeout.
above
That would be
1500.
horrible. Can you imagine
Bottom,
if I
bottom.
accidentally made if I accidentally timed him out? Oh man, we're all sitting here waiting for the timeout to finish. Hopefully, if I keep doing him with Thomas, then I won't be doing him with someone who's less than 1500. I guess.
I think I'm between 15 and 1600. But I'm not sure.
Okay. So we have 2 cases left here. We're gonna see if we can beat Bless's Fingers of Fire. Bloodest is the real MVP of this stream. N mod 4 equals 1, and we have n mod 4 equals 3. So these are the question marks. Okay, so what is the 1 equal? Now we've got odd numbers, so this powers the 2 thing is going to get annoying.
Yeah.
So we've got like 11, 9, 7, 5, 3, 1. Does the 1 matter? 1 doesn't matter. Seems tricky. It's 1419. Ah, there you go. Guess he is under it. Take the answer for n minus 1, use it for n. Oh! Genius! Do you see that, Thomas? Thomas?
And
you see it?
Use it.
Look. So, we have the answer for any n mod 4, right?
Yeah.
Look, we have the answer for any n mod 4. If we add 1 to n, if we make n 1 bigger, we can just get rid of this last thing.
Oh.
Like, instead of doing this 11, we can just get rid of the 11
Yeah,
and
yeah.
then do it for 10.
Yeah.
And now we have these 2. This uses 2, this uses 1. So we're going to use at most 3.
Yeah, I see.
So we just need to see whether it's 1 or 2.
Okay.
Does that make sense?
Yeah, kinda.
Like, so like what like we've got 11, 10, 9, 8, 10, 9, 8, 9, 8, 8, and so on. So we'll just like erase this number, and now we can do it with 2 more always because we know we're even.
Yeah.
Oh, that's so cool. Okay, so now the question is just, is there ever potentially a better way of doing it? Because we can definitely do it removing 3 numbers worst case. But we might be able to do it removing 2 numbers or removing just 1 number.
Yeah.
And I think you can do that with hashing. That's where geothermal's hashing was coming in. So when we saw his stream, I saw he was doing some stuff with hashing. And the hashing is just like you have some bit mask, right? So, yeah, okay. Here's how you do it. So, okay, cool. So someone's proven that with very much help from Bloodest, we have shown that like it takes at most 3 things to remove. So then, okay, pause this for a moment. On top of that, so now like, okay, we can check whether it takes 1. Oh, we have 2 issues. We have the 2 still. All right, we'll read chat in just a moment. We live in the great state of Wisconsin.
Yeah.
Cheeseheads all the way. So Wisconsin, United States.
Wait, what?
In case that's not obvious. What did you say? Yeah. So this is the hashing thing.
Oh, okay.
Yeah. So the random 64-bit number. Is that what you're
Yeah.
reading? Yeah, that's hashing. Wait, so okay, so we can do the Bloodest. We can check the n minus 1 is easy, but the n minus 2 part is a bit tricky. So bear with us for a moment here. But for the n minus 1 part, like, okay, so here's what we'll do. Like, for 1, you just have the empty set. For 2, you take the previous thing and then you change it in a small way. So you have like log n prime factors. So for 2, you have the 2. For 3, you've got the 2 and the 3. For 4, you also have the 2 and the 3. For 5, you've got the 2, the 3, and then the 5. For 6, you have just the 5. Maybe we'll just do just the 5. There you go, that's a better way of doing this. For 7, you have the 5 and the 7. For 8, you have the 5, the 7, and then this 8. So you can represent this as like a bit mask. And then for each prime, you have like a random, like this is just a number in binary, right?
Sure.
So this is like, this is 0, this is 1, this is 3, this is 3, this is 7, this is 4, right? So this is just a number in binary.
Yeah.
So we just want to store this number in binary, but like store the whole thing. Obviously we can't store the whole thing, so we'll store it under some big prime mod.
Oh, I see.
So if 2 numbers are equal, that means they're very likely going to be equal. And that's not good enough, so we'll store it under 2 prime mods, so now they both have to be equal. So we can easily add and remove stuff, and so on. So yeah, we can store this like each of these will give us a hash, which is just like this bit mask
XOR, right?
under mod. Yeah. So
yeah, that makes sense a little bit.
yeah. So okay, so then the question is like, we have our final, like we have everything. We need to see if we can do it in 2 though. Because like if we end up with the answer of 1, like if we just need to remove one of these to make it work, that's easy to check. Because you just like see for each thing, like does your bit mask? Oh, use a hash set. All right. Wait, does that work? Maybe it doesn't. Okay, so how do you do it for 1?
Well, yeah.
For 1, let's slow down a minute. For 1, if you have like, let's say the thing we're left with, if you do all of these, let's say you just end up with like a 5.
You can't use prime mod.
Why can't you use a prime mod?
You should use a random 64-bit integer for each prime.
No, you can use a prime mod. I don't believe you. Why can't you use a prime mod? You can use a prime mod. We'll use a random prime mod. Use like big integer.next probable prime. Use a prime mod. You can use a prime mod. Nonsense. Well, yeah, like don't use just a prime mod because you get hacked, but use. Yeah, you can use a prime mod. Just like a random big prime mod. What you can. Okay, well, I don't know. He solved the problem and I haven't, so maybe I'll listen to him. But I think a prime mod should be fine. Like you're just storing a bit mask, right? Yeah, you're just storing a bit mask as like some power of 2 number. You just store it under mod of some big random prime. But like, okay, the question is still, how do we check the difference between it taking? You have to remove 2 numbers and you have to remove 3. We still don't have that figured out. Like for removing 1, if the answer is 5, we just want to see like it's 5. Is there anything that's left being 5? Oh, here's how. Yeah. Okay. So you want to check. Okay, so here's how I done this. So do you see how to check for 1? Like check if you remove 1 thing, because you have to understand that first.
No.
Okay, so basically each of these are like a bit mask.
Yeah.
And we have them all represented as hashes.
Yeah.
So we can check very quickly. So then, what we say is like, if you take the XOR of all of these, let's say this XOR is equal to just the 5. It's not, but let's pretend it is.
Okay, yeah.
Now we just need to see, is there any number that's equal to just this 5?
Oh, I see.
And yes, there is. It's the 6.
And you can
It's
do
the
that
bit
with a
mask
hash
of the
set.
5. Yeah, if we have all these things in a hash set, we just say, is there anything that matches this? If there is, we can just remove this 6.
Is there any? Yeah, okay, this makes sense.
Right? So then,
hash set, sure.
well, we can just iterate through all of them even.
Yeah, this is fine. Okay.
So this is fine. The issue is, what if there are 2 things we have to remove? So in the example they gave, you had to remove like 8 and 3.
Okay.
Does that make sense?
Yeah.
So to remove the 8 and the 3, it's a bit more tricky. So what you do there is you brute force one of them.
Oh, you can do that.
Yeah, because it's XOR. So we'll also have the 9 here. What is the 9? So 9 is the same as 8. So it's 2, 5, and 7. So if we brute force one of them, let's say we brute force the 3. What are we left with? So this has 1, 2, 3, 4, 5. So we
you
have
get
this
rid of
bit,
2.
we have this bit, and we have
You get
this
rid
bit,
of
right?
7. Yep. You need to get rid of a 5. 2, 7, 5.
So yeah, these are the bits that are left.
So we should get rid of a 9.
But the fact that these bits are left is really easy to figure out because we have the XOR of everything and we have the XOR of this.
Yeah.
So we can look at this number up in a hash map.
Can we get rid of the 8 or the 9?
Yes.
Oh, there you go. 2 solutions.
Guys, that was legendary. What a great problem. What a good problem. Okay. Why are they not beating each other up? Because we're brothers. Oh man, that's good. We are really brothers, yes. Yes. Alright. Oh, thank you guys for watching. That was terrific. Well done. Yeah.
You should make a Discord.
People have said that.
There's a
Lots of
second
people
thread
have.
Discord coming soon.
Um,
You should make a Discord.
it's been promised. What can I say? Give your thanks to
Hey,
Neon.
put a 1 in the chat if you want a Discord.
Neon, this is a great problem. If you want to be mod for writing such a great problem, I'll let you be mod on my stream as well. And Bloodest, thank you so much for the the solutions. It was very helpful. Appreciate it.
Oh, look at all the ones.
I'm not active on Discord. Oh man. Oh no.
Oh yeah, Discord! Yay!
Oh no. This is so much work I've been signed up for now. Moderating
okay.
a Discord.
Well, you can. You got Light. We can do moderation for you.
Yeah, they're okay. All right. Well. Yeah, Light. Will you help me moderate my Discord, Light? We've got lots of existing Discords. Is the thing. There's so many of them. Highlight Sam. Okay. That's all we have to talk about today. Hopefully you guys enjoyed. This was a terrific contest. Neon, thank you for the brilliant problem. That was so. The fact that it all just works out is absolutely incredible.
That's pretty cool.
One of my favorite problems that I haven't solved. So, there you go. Yeah, someday there will be more people watching. I mean, maybe if it gets big enough by Code Forces, maybe we'll get geothermal in here one day. How
Yeah.
cool would that be? Dude, that would be awesome. Although, to be fair, crowdsourcing it with chat was also pretty fun. Well, Neon Chad, indeed. Thank you guys for watching. That's all. Have a great day, and we'll see you in the contest tomorrow. I don't know if we'll live stream it. You don't know live stream, Thomas?
Yeah, I'm doing a live stream, probably.
All right. Be back tomorrow after the Div 2. See you
Bye,
guys.
everyone.